Second problem. A Chinese engineering company is planning to design a train that reduces energy loss to friction by levitation. They develop a technology that permanently traps charged particles in an insulated material. This material will be used for the bottom of the train and the tracks, effectively creating a flying train. Each car of the train will have a mass of this. Unloaded, each car of the train will have a capacity of 160 passengers. The train will consist of 12 cars. How many electrons must be located on the track and on the train's cars to maintain levitation? What are some of the possible dangers if you see this plan? This technology reduces the force, yada yada yada. So there's a lot of important things in here. So it's we're going to make an effectively flying train. That's pretty important. Here is the mass of one of our train cars. Each car holds 160 passengers. There are 12 cars. So these are all really important things for the first question. And save this stuff. This is going to be right here. This is for the second question. There's basically two key things. The first one is as how many, this right here, but also the second, another question is this right here, that right there. So these are our two questions we're looking for. The first thing we have to develop a nice understanding of what's going on here. I've drawn a little picture in Paint. Let's shrink this down so we can see it better. So we've got our train. Here's our train, and here's the tracks below it. So train, tracks. And what we're actually going to be doing is you're going to be putting electrons. So I'm going to spray paint some electrons here. You put electrons here, and you're going to put electrons here, and you're going to make this train fly. So we've got electrons here and electrons there, and it's going to make this train levitate. Now we have to think about, well, what forces are acting on our train? Well, and I'm going to use these big weird arrows. What pulls our train down? And that's going to be what pulls our train down. That's the force of gravity. What's going to push it back up? Well, that's going to be our electrostatic force. So in this situation, I would start off by saying that the electrostatic force that's going to push up, Fe. What's going to pull down is Fq. So, or I'm sorry, Fg. So you have to start off by saying Fe equals Fg. And put those formulas equal to each other. You should have both those in your notes if you don't have them. In this case, guys, we assume we're on the planet Earth, so Fg equals mg. That would be great. And this one, you're given that in the class this week. I think it's k q1 q2 over r squared. So set these equal to each other, and you should be able to come up with some answers. Now, you may have to do some guesses, but you should be able to, you have to make some assumptions, think about it thoroughly. It's not too difficult. You can do it.